My name is Tina D. Barnes and welcome to CH141A. Now, since I'm running on 2-3 minutes of sleep, let's go straight to Module 1. Now with Module 1, we got states of substances. We start with solid, the molecule that make up the solid, arranged in regular repeated pattern. They are tight and firm. Next, liquid. The molecule that make up liquid flow easily around. It's easy to move around. And when it's easy to move around, this means it could fill into any tiny cracks that you could see. See the tiny little cracks over there? It's gonna go in there. It's liquid. Don't try to fight it. You can't stop the liquid. It will find its way into every little tiny cracks in that jar you have right there. So it's no use to you. You can throw it away now. Next, gas. It's the molecule that make up a gas that fly in all directions. It's a free-floating molecule, and same like liquid, if there's a crack, it will find a way through it, no matter how small. So be careful of gas leaking in your house. Have a regular maintenance going on your house to make sure you don't want it to go boom one night or fall asleep and never wake up again. Next, plasma. What in the world is this? So basically, plasma is a state of matter consisting of free charged particles like lightning, solar wind, aurora, fluorescent light, and nuclear fireball. Next, type of mixtures and pure substances. Now there's two type of mixtures going on here. Heterogeneous mixtures and homogeneous mixture, or genus, or genus, I don't know. Anyway, as you can see, heterogeneous mixture mean, well, hetero. It's separated. It's not mixing. As you can see, the purple and the green dots molecule over there is not mixing. While homogeneous, homo, which means the same or could be combined, is mixing, combining each other perfectly over there. Now let's move over to pure substances versus mixture. Pure substances are made of only matters, so the composition is the same throughout. The chemical and physical property are constant and can be categorized as gas, liquid, and solid. For example, water, hydrogen, gas, or gold. Meanwhile, on the mixture part, they are made of several substances that are not chemically bonded. Chemical and physical property may vary. They categorize as homogeneous and heterogeneous, which we already went over in the last panel over there. For example, this could be sand, sugar, oil, or water. Next, hold on to your pants. We're about to get into units of measurements. We're starting with the biggest one, which is giga, and then mega, kilo, deci, centi, milli, micro, nano, and the smallest units of measure, pico or pico.
But Miss Barnes, I think you're missing something.
Shut up, polite voices in my head. I don't need your help here. I know what I'm doing. There's another important unit of measure in chemistry that we will be using a lot in chemistry, which is moles. What mole? That mole? No, this mole. Moles is basically the base of unit, which is defined exactly as that number that I can't read out right there. And can be atoms using, weighing atoms, molecule, ion, or electrons. Next, accuracy and precision. With high accuracy and precision, you will hit your mark with higher concentration on the mark. Nothing will scatter around and you will stay on your target. Low accuracy and low precision, which means, well, you miss your mark, and not only that, you can't even aim in one direction enough to stay in one spot. While when you have high accuracy but low precision, which means you will hit your target, but your concentration is not there and you just kind of scatter around. You're not in one point, but you're in the area. And lastly, not accurate, but precise. You missed your target, but somehow you could stay focused in one spot enough to have a high concentration. Good. Module 2. The Vespasian theory. Valence shell electron pair repulsion theory, or VSEPR theory, is the model used in chemistry to predict the geometry of the individual molecules. As you can see, the total amount of domains depict the, shape, molecular shape, electron geometry, and all that stuff. Like with one domain, you're gonna have a linear molecular shape, electron geometry is linear. Up to 3 will be a bunch of weird names. Just look at the picture. The more domains you have, the more shapes you could form depending on what element you're binding and all that stuff. Like with the fourth domain, you have tetrahedral, triangular, pyramid, bend, and linear. And I believe you have up to 6 domains. Fun. Next, module 3. Oh, how to determine molar mass? We already been through this. The molar mass is equal to the mass of the substance divided by the moles. Next, empirical and molecular formula. Empirical formula is not often used in the reaction scheme, unlike the molecular formula. Empirical formula is a simplest form of expressing elemental composition of a compound, while the molecular formula is an actual representation of the element compound. So the empirical formula is like one of those kind teachers who would curve up your grade average in your class, while the molecular one will give you a C instead of a B when you have 79.9999% in your grade average. Next, balancing chemical reaction. Oh boy, where do I even start? Everything should be balanced or it's not gonna work. So let's start with writing out the equation first, just to know what you're balancing. Then you balance out the amount of atoms on each side until both of them are equal to each other. Confused? Me too. Now let's look at this. Step 1, set out your equation. Step 2, is it balanced? No? Okay, go to step 3. Balance out the electron and the charges. C equal 1, C equal 1, balance. H equal 4, H equal 1, not balanced. Cut it out, make it 4. C out chlorine is 2 equals C out chlorine of 5. Nope, not balanced. Cut it out, make it 8. Done. Next, look at these hot dogs because we're going to be talking about the limiting reactant, and I'm going to give you 2 examples of how to do this. The limiting reactant is what runs out first. If you run out of that thing, you can't make any other things out, which means that's limiting the thing. Right, we have 5 hot dogs, 4 buns, and we want to make hot dog in a buns. Of course, with 4 buns, you can only have 4 hot dog buns, and you're going to be left over with 1 hot dog, which means the bun is the limiting reactant because it stopped the progress of making the hot dog in the bun, because the buns will run out first. Now apply that logic into chemistry. Now we've got 6 grams of hydrogen, 28 grams of nitrogen, and we're trying to make nitrogen hydroxide. So obviously, the hydrogen will run out first because you only have 6 grams of hydrogen and you have 28 grams of nitrogen. So I can't make nitrogen hydroxide without the hydroxide part of the hydroxide. Next, acids, bases, and salts, or what we call polyatomic ions. Bases will contain a metal or hydroxide ion, or OH -1. An example of bases would be sodium bicarbonate or baking soda, ammonia hydroxide or ammonia water. Next, and salts or polyatomic ion are ionic compounds that start with a metal and end with any ion except OH -1. An example of acid would be anything acidic like a citric acid like lemon, vinegar, or anything on the lower scale of the pH scale. And that's it for this video. I've learned so much in this course, I can't fit all of the material that I learned so far into just one video without it exceeding 1 hour. But these are all I know. Bye!